Okay, here's a video on factoring trinomials. We're going to focus on trinomials, quadratic trinomials, and where the leading coefficient is not equal to 1 today. Remember that factoring is the reverse of multiplication. The first thing you should look for is a greatest common factor and factor that out if possible. You always need to make sure that your leading coefficient is positive as well. And then I'm going to focus on the box method today. But you can use reverse distribution to factor as well. But this video will focus on the box method. So here's a couple warm-up problems to just kind of review greatest common factor and factor in what we've looked at before. So greatest common factor between 2, 14, and 20, or the biggest number you can divide them all by, is 2. Now if you look at your variable terms, you have an x cubed, an x squared, and an x. The biggest number, the biggest x you could divide them all by is an x to the first power. So if I divide them all by 2x, I put that greatest common factor 2x up front, and then 2 divided by 2 is 1, x cubed divided by x is x squared. Here 14 divided by 2 is 7, x squared divided by x is just x, and 20x divided by 2x will be 10. Okay, now I'm going to see if I can factor this any further. So my question is, can I factor this trinomial into two binomial factors? So I'm going to use my box method. The first term in my trinomial goes in my first box. So I put my 1x squared right there. And then the last term from the trinomial goes in the last box. So you get your positive 10 here. Then you need to find these two diagonals, need to add up to the middle term. So those two diagonals need to add up to 7x. Okay, I use the x squared to help me out. I take a times c, so 1, remember this is a, b, c are my coefficients here. So 1 times 10. A times c is going to be 10, and I need to find numbers that multiply to 10 and add up to my b term, or add up to my 7. So two numbers that multiply to 10 and add up to 7. That's going to be positive 2 and positive 5. Now these two values become my diagonal values. Whoops, made a mistake there. It should be 2x and 5x. Then the goal is to figure out the outside of the box. So the only way to get 1x squared is x times x. And so then x times what goes here to get 2x, it has to be a 2. And then x times 5 would be 5x, and then 2 times 5 is 10. So it's kind of like lattice multiplication, where you take row by column and multiply to get the outside of the box. And then it's a good way to check. You get x squared plus 7x plus 10. So then here I have an x and a positive 2, so that's the factor x plus 2. On this side you have the factor is x and positive 5, so you have x plus 5. So that's my final answer. Don't forget to put the 2x out front, the greatest common factor that you took out. The second example, looking for a greatest common factor, this time I can take out an 8, and then remember my leading coefficient, or my a value, I always want that to be positive. So I actually need to take out a negative 8. So if I divide everything by negative 8, what's going to be left is just m squared. It's going to be minus 4m, and then negative divided by negative is going to be plus 4. So now I want to see if I can factor this trinomial that's left. So can I factor that trinomial any further into two factors? And I'm going to use my box method. I'm only looking at the m squared minus 4m plus 4, so I put my first term here and my last term here. Again, the first term, the m squared, goes in the first box, and then the 4 on the end goes right here, this 4. Then you do the a times c. A times c is going to be 1 times 4 is 4. and I want to find factors of 4 that are going to add up to my middle term. My middle term is negative 4m. So I need factors of 4 that add up to negative 4. So two numbers that multiply to 4 but add up to negative 4. That's going to be negative 2 and negative 2. These numbers are going to be the numbers that go in my diagonal with my variables. That's the negative 2 plus negative 2 gives me that negative 4m. So then I can figure out the outside of my box from there. M squared is m times m. There's no other way to do that. So it kind of takes the guesswork out of it. The only way to get m squared is m times m. Then m times negative 2 is negative 2m, and m times negative 2 is negative 2m again. So this one factors to m minus 2 and m minus 2. You could write that as negative 8 times m minus 2 squared, like negative 8 times m minus 2 squared. It can be written like that as well, but okay. So I'm actually not going to show the second method in this video, but the first method I'm going to show is this box method. If you'd like to see the second method, I have some older videos out there that does show that. So you're more than welcome to look that up. But the box method, again, first term goes in the first box, last term goes in the last box. And I guess I skipped the step of looking for the greatest common factor because I knew this problem wouldn't have one here, but you should always check. 2, 11, and 6 are not divisible by the same thing at all, so there's no greatest common factor between the numbers, and you can't take out an x because the 6 doesn't have one, so there is no GCF. So first term goes here, last term goes here. You're going to find the product of those two, or the A times the C. So A times C is going to be 2 times negative 6 is negative 12. And you have to find the product of A and C that add up to B. Our B is negative 11. So two numbers that multiply to 12 but add up to 11. It's going to be negative 12 and positive 1. Then these two values that you found here go in the diagonals with the x's. Negative 12x and 1x. Remember, those had to have added up to negative 11x. So right now I have my trinomial up here, 2x squared minus 11x minus 6. So now you just need to figure out the outside of your box. A is no longer 1, so it's not just x squared times x squared anymore. You have to get 2x squared. The only way to make that is 2x times 1x. So where does the 2 go and where does the 1 go? A good way to figure it out is looking at the greatest common factor. So if you look at the greatest common factor of this row right here, 2x squared and 12x, 2 and 12 are both divisible by 2. So you can take the greatest common factor of 2x there. You can take out a 2 and an x from each, which means the 1x has to go right here, which makes sense since there's a 1x right here. Now 1x times what is 1x? Well, that means there has to be a 1 here for this row times this column to equal 1x. Then 2x times negative 6 would give me the negative 12x here. Then just to double check the last row, 1 times the last column, negative 6, 1 times negative 6 is negative 6. So that is my answer. I just need to write that out. It's the factors 1x minus 6, which is just x minus 6, times 2x plus 1. 2x plus 1. So those are my two factors. Again, I'm not going to show the reverse multiplication method or the reverse distribution method. That method is in another older video if you'd like to see it. Okay, a couple more examples using the box. So we start out, we draw it. We put our first term in our first box, and our last term in our last box. I should have did those with different colors just for emphasis. We'll do that in orange. So the 2x squared goes here, and the 6 goes here. Then you do a times c, which is ac, and you want the product of ac, so a times C, and then it has to add up to B. So 2 times 6 is 12, and then the middle has to add up to 7x. That's our B. The numbers that multiply together to give me 12, but add up to 7. So that'd be 3 and 4. And these go along the diagonal here. So you get 3x and 4x, and then we can check that next here to make that equal 7, whatever our middle term was. Then we just figure out the outside of the box. Again, we have a 2x squared, so we need to decide, it's going to be 2x times 1x, but where does the 2 go? You think about it, you can't put the 2 here because there's nothing you can take 2 times anything to get 3. So that's a process of elimination. I know the 2x has to go here and the 1x has to go here then. But there's a greatest common factor method that works too. In this column itself, 2x squared and 4x have a GCF of 2x, so that we pull that out up here. Between 2x squared and 3x, their GCF is 1. Then 2x times 2 gives me 4x, and 1x times 3 gives me 3x. So we got 2x plus 3 and x plus 2. So remember, this is plus and plus because they're both positive. All right, I'm going to go through this one a little bit quicker, but we have 2x squared and negative 20, first and last term. The middle has to add up to negative 3x. We want a times c, so that's my diagonals here, that's negative 40, and I want the two numbers that multiply to negative 40 and add up to my b term, which would be negative 3. 40 has a lot of factors, so you might need to list them. 1 and 40, 2 and 20, 4 and 10, 5 and 8. And then once you see one that works, 5 and 8 has a difference of 3. And if I want negative 3, 8 has to be negative. And then those are the numbers you're going to use to fill in the diagonals. It doesn't matter where you put it, as long as you fill out the outside of the box at the very end. 2x squared, so I have to do 2x and 1x. I can't put the 2x here because then I can't get a 5 here. So I have to put the 2x here, which means 1x has to go here. 2x times 1x is 2x squared. 2x times negative 4 is negative 8x. 1x times 5 is 5x. And then 5 times negative 4 is negative 20. So it does work. Then writing the answer, it doesn't matter in either order. Multiplication is commutative. You can write this factor first, 2x plus 5, because it's positive 5, and x minus 4. Or you could have written it as x minus 4 and 2x plus 5. Either order is the same thing because multiplication is commutative. 3 times 4 is the same thing as 4 times 3. All right, last two examples. Here, I notice it stands out right away because I have a trinomial, but it's a cubic trinomial in this example because the degree is 3. So that tells me that I probably have to take out a GCF. Also, 6, 15, and 9 are all divisible by 3. That means I'm going to take out a 3x before I do that. I'm going to get 2x squared minus 5x minus 3. And then from there, I can see if I can factor it any further. So 3x, and can I factor it down further to 2 factors from this trinomial? I'm going to use my box method. I'm just factoring the trinomial that's left here, so the 2x squared and then the negative 3. A times c is going to be negative 6. 2 times negative 3, and then I want that to add up to negative 5, because that's what these diagonal has to add up to, because that's the middle term. So factors of negative 6 that add up to negative 5 is going to be negative 6 and 1. So negative 6x and 1x, it didn't matter where I put those, I could have reversed them. I would have ended up getting the same answer in the end, because I'm going to do the outside last. If it's 2x squared, if it's 2x times 1x. I knew the 2x was here because that's the greatest common factor between this row. I also knew that I couldn't put the 2x here because I had a 1x here. And I know that 2x times negative 3 will give me negative 6x, and 1x times 1 will give me 1x. So I have x minus 3 and 2x plus 1. I do this step right away so that I don't forget to include my greatest common factor in my final answer. All right, the very last example. A leading coefficient must be a positive, so I can't have a negative leading coefficient here. So I either have to take out a -1, or is there another greatest common factor I can take out? So between 12, 56, and 32, let's see. 56 isn't divisible by, well, 32 isn't divisible by 12. How about 3? 56, you can't divide by 3. How about 4? I think you can divide them all by 4. Yeah, 56 divided by 4 would be 14. So, and 32 is 8. So I think I can take out a 4. And specifically, I want to take out a -4. So to make that leading coefficient positive, which would be 3x squared minus 14x and then plus 8. If I didn't take out the greatest common factor, I would have had a multiple of 2 still in here. Like if I would have only divided by 2, I would have got 6x squared minus 28x plus 16. So it would have been obvious that I could take out another 2. So you want to make sure you take out the greatest common factor, the biggest one. Then can I factor this any further? It's not always possible, but I'm going to give it a try here. I'm focusing on just factoring this. So this first term will go in the first box. The last term will go in the last box. The diagonals have to add up to the middle term there. So we got 3x squared, positive 8, and I want to add up to -14 down this diagonal. So these diagonals I multiply, that's my a times c. That'd be 3 times 8 is 24. I want them to add up to -14. So 24, let's see, we got 2 and 12. Yeah, 2 and 12 would work. 6 and 4, but 2 and 12 work, they just both have to be negative, because 2 negatives multiply to a positive still, but then they add up to -14. So -2x and -12x. If possible, a multiplication chart is helpful. If you need some help with your multiplication, like basic facts, that could be helpful. Otherwise, guessing and checking with a calculator, dividing by 2, then 3, then 4. That's another way to get those factors if you have trouble thinking about them on the top of your head. I'm better at some numbers than others. So 3x squared, I can either do 3x or 1x. I just have to be careful where I place it. So the greatest common factor between 2x squared and, or 3x squared and 2x, the only thing you can divide 2 and 3 both by is 1, so the 1x has to go there. If I look in this row, 3 and 12 are both divisible by 3, so I can put the 3x up there. Then 3x times -4 would be this row times this column would give me -12x. 1x times -2 would be -2x. And then -2 times -4 is 8, so that works out, just to double check. Once you have this box, it really lets you check your answer, because you have 3x squared minus 14x plus 8. That's what you started with. So it's another way to double check that your answer is correct. And it always works if the trinomial is factorable. Not all trinomials are factorable. That is something you have to look for. But if they are factorable, you can use this method. Look for the video on special cases to when we talk about difference perfect squares and perfect square trinomials. Remember to always factor out any greatest common factors. Check your answers. You can check your answers by multiplying it back out with the box or using FOIL, but always check your answers. I showed the box method today. All right.